So good afternoon everyone. So we will start today's session within a few minutes. So we will wait for others. So I am sharing the screen. I hope the screen is visible. So we will start today's session. So first of all, to you. Let me introduce myself. I am Niloy from IIT Bhubaneswar, a PhD scholar, and I am taking this live interactive session on this fluid mechanics topic. So previously, I have also completed 5 sessions, and this is our sixth live interactive session. So the course instructor is Professor Shubhashish Datta from IIT Guwahati, and I hope that you have gone through these lectures. So coming to this subject, so this is an interdisciplinary subject, and you know that it is quite vital for the student in civil engineering, mechanical engineering, chemical engineering. So the student will know how to solve this problem, like the real life problem, based on this concept of flow or the fluid. So that will really enhance the student's capability and interest in this subject. So what we have already discussed in this in week 5 or this last week is that we have solved few numerical based on this application of fluid static and also on this conservation of momentum and Bernoulli's equation. So if you have missed this topic or these courses, so you can go through this uploaded link of this video, and you will easily get to know what are the topics that has been taught in this interactive session. So it will be better if you go through this topic, so as each topic is interlinked with the next one, so that will be vital for you. So in this week we will deal with this fluid kinematics. So we will deal with some sample problems on this Lagrangian and Eulerian description, and also this motion and deformation of this fluid element. So basically, if I talk about this Lagrangian, see there are what the first one is the Lagrangian. So what exactly it means? So it means an approach where our target is to track individual fluid particle. Maybe the particle is at rest or it can move. So I can write as they move. So that is the fundamental of this Lagrangian approach. So what say in a space a particle is at a position say x comma y comma z at time t, right? So at time t equal to 0, that initially it is at this position. So if at a later position, say at time t, any t, so I do not know about this position. So I write this position as a function of, just a minute, x comma y comma z and t, right? So that indicates the position of this particle. Okay, so the Lagrangian approach track this individual fluid particle, so that is the position of the particle. So we know that if you have to find out this velocity, we have to derivative it with respect to time, right? So if I derivative it with respect to time, what I will get? I will get this velocity, and similarly if I derivative it with respect to time, this velocity 1, we will get acceleration. Accordingly I can describe about describe about this velocity of this same particle throughout this path, the path in which it is moving. Okay. So next, if I talk about this Eulerian approach, so what basically this approach is? So this basic approach basically focus on a fixed point in a space. Say in the previous concept, what it was? So it was on an individual fluid particle on this one. So actually I have to track this particle, right? So here we have to just the point is fixed. The point is not moving. It is in the space and this point is not moving. So at that moment, whatever is passing through this point, we have to look upon this thing. So over a certain period of time, say time t, right? So at say this location, say at each location, say x, y, z. So say this is the location. So in these cases, as in this point, the velocity of the particle can change, the acceleration change, because at a certain time another thing can pass through this point, specific point. So if there is a velocity, then velocity should be a function of this x, y, z and t, right? In the previous case, it was initially we describe this position of this particle and then we can find out this velocity. But here we have to deal with this velocity, pressure, density over time. So basically the main objective is that it focus on fixed point in space and describe how fluid properties. What are these fluid properties? So the fluid properties are, say, velocity, say pressure, say density, like this. So and it should be over a certain period of time, right? So that is the fundamental of this Eulerian approach. Okay. So, so if I say this thing, so it's like you are in case of Lagrangian. Suppose you are sitting in a car and this car is moving. So that is the Lagrangian approach, and Eulerian approach is a suppose you are standing in a traffic post and you are seeing the car moving through this road. So that is the Eulerian approach. So that is basically this difference. So in the exam, certain question may comes to where you are asked to find this difference, write about this difference between these two approach. Okay. So I am moving to this numerical on based on this concept. So this is the first question. So in this first question, what exactly it is told? So here it is told that this actual path traveled by a individual fluid particle over some period is known as what? So these four options are given. This is path line, stream tube, streamline, streak line. So these four terms are given. I think that you people have gone through this lecture in the class lecture. So I am just giving you 1 minute time to answer this thing. So please try. Mm, So Shivam, you can try. Mm, So you have response option C. Okay. Let me go through this option. So it's the correct option, right? No, so it's not the correct option. So this the so exactly if the actual path travel by this individual fluid particle over some period, then it is known as path line. So I am giving you this definition regarding all these four points. So basically, if I talk about this path line, it is basically it's a trajectory of a single point, full fluid particle. So if it is moving in space over a time, like whatever I have taught about this Lagrangian approach, if I track its path line, then it is known as this. Then it is this path line. So next is this streamline. So streamline basically is a curve. So if I know this velocity at a point, say this is the velocity at a point, this is the velocity at next point, right? So this is the path of the. So if I draw tangent, right, at this point, so in each and every point we can draw some tangent through this fluid particle. That trajectory is known as this streamline. So basically it is at a instant, not the, it doesn't depends on the previous one. It talks about the current or the initial status of this particle, right? And if I talk about this straight line, mm, so this is a fixed point. Say this is a point. So a particle is coming, it may move through this point. Another particle is coming, it may move through this point. Similarly, a large number of particles can pass through this point. So if I track the locus of all these points which is passing through this given point, then this is known as streak line. Okay. So streak line basically is the locus of all the particles that passes through a fixed point. And another that is remaining is the stream tube. So it is basically a bundle of streamline. So you have understand the streamline, right? So it is basically a curve where the tangent to this instant, it is basically a curve where it, say this is the point, right? This is a point and its velocity is there. Okay. So this particle is flowing like that way. Say this particle is flowing like that. So if you draw this tangent, this is known as the streamline. So this is for one particle. Say another particle is there. So if you draw another tangent, then this is your streamline. Similarly, if you draw for another particle, then this is the streamline for another particle. So if we combine all these streamline together, then it will appear like a tube or it will appear like a cylinder. So that is known as stream tube. So in our question, as it is asked about the path of a individual fluid particle, and also it is mentioned that this particle is observed for some period of time, so it should be this path line. So the correct option is the path line. Okay. So I'm moving to this next one. So in this next question, what is told? So it is told that the vorticity in a region of the flow is 0. So given the vorticity is 0, so then you are asked, then at this case what this flow is known as. Mm, so you please try. Okay. Shiva has already answered. So C. Yes, this one is correct, Shivam. Okay, let me clarify this concept for you, for all others. So what basically this vorticity is, right? You know, vorticity. So say I represent it as omega. Omega is equal to curl of this one, right? Velocity field, is it? Hmm. So say in this question that given omega is 0, right? So that means this curl term should be 0, and we know that if for a certain term curl is 0, that means it corresponds to irrotational. So that is the fundamental of a curl, right? Okay. So if I talk about that's why the correct answer is irrotational. So another three options. So rotational should not be the answer because as omega is 0, then there it should be irrotational. So there should it should not be rotational. So another two option is incompressible and compressible. Say compressible and incompressible, both these two terms basically depends not on the curl, it depends on the divergence. Always remember this thing. If someone talks about this incompressible or compressible, you should remember that it should depends on the divergence. So that means del dot v. Okay. So if del dot v is 0, then at this can we can check whether this certain condition is fulfilled or not, or any other values if it gives. But in this question nothing is given about this. uh, so these two terms are not related to this vorticity, right? So the correct option is it should be irrotational. Okay, so that is the huh. So the third question is this angular velocity. The angular velocity of a fluid particle is given 40 radian per second. So you are asked to find this vorticity of this fluid particle. So for this question I am giving you 1 to 2 minute time. So you use your basic concept about this vorticity and the formula that I have already given. So I think that you can able to answer this one. I am giving you 1 to 2 minutes. So please try. So Shivam has responded option C. So I have to check whether your answer is correct or not. So let us solve this one. Okay. So what we know, first I am writing what we have studied. So this vorticity omega, so I represent this vorticity as omega, so this one is right. So again we know this velocity v equal to angular velocity into radius vector. So I can write this angular velocity as omega into r. So this one is your angular velocity. You know this thing even for class 10, 11, 12, that v equal to omega r. So this one is omega, as I have represented this vorticity as omega. So this term I have represented vorticity as omega, then I have just changes is representation. Okay, that is for representation purpose. Ohm, not omega, this one is ohm. Okay, so since it's a velocity, so that this angular velocity is given at a certain direction. So this direction, so I do not have any details about this direction. So let us assume for this. So this one, let us assume this one is ohm. So why I have taken this one? So I considered that, see this finger. So this finger, if I know if it's an a vector and a b vector, then this cross vector should be perpendicular, right? So for a certain cases, I am considered this as ohm, right? And this r vector I don't know, so I consider this r vector in x and y direction. You got it? So why I am taking this one? Because I am considering this fluid particle is rotating along z direction. So I am you consider, if you considering along y direction, then this r vector should be x, 0, z. So accordingly you can choose, right? So it's a cross product. So if it's a cross product, so I can write this velocity v. Okay. So how I can find this velocity cross product? So it should be I cap, j cap, k cap, and in place of omega this is, and this one is x, y, 0. So for this first I1, it should be 0 minus sigma y. Similarly, for z, anything is there, 0 minus this x, and for k, it should be into 0. So that is minus y I cap plus ohm j k cap. That one is the vector, right? So I got this velocity v is minus y I cap plus, right? That is the thing I have got. Okay. So as this we have assumed that it is moving in the z direction, so I just have to find out this vorticity component in the z direction. So let us find this vorticity is a cross product. So that means what delta is I back j cap k cap, and this one is corresponds to d dx, d dy, d dz, and in place of this one minus sigma y, and this one is 0, right? So now you can find, so we have to find only in this z direction, right? So z direction means this direction. I am talking about this k1. So what I will get, this one and this one minus, is it? Any confusion? Okay. There is a mistake in here. That is x here. No, this is y. This is x. This one is x. So that one derivative of this one is like this one minus, and derivative of this one is minus of minus 2. So that is 2 sigma, 2 ohm. So given what is given, we have to find what has been asked. We have to find ohm z, that is this by 2. No, sorry. So we have to find this vorticity. So what I have got this vorticity as 2 into angular velocity. What is the angular velocity? Is 40. So I will get it as 80. So the correct option is option C. So you got my point, why I have done this. So initially basically is based on this formulation. As we know, this formula of this vorticity, which is del is curl vector of velocity field. So now we do not have any details about this velocity field. So first I found out this velocity field. So just this angular velocity is given. So I do not know about this exact whether it is in x direction, y direction, z direction. So I consider the common assumption that is z direction. So that's why this uh, ohm is 0 comma 0 comma this one ohm, right? So that is in z direction, and the r vector also they have to, since since a particle has angular velocity in z direction, so this so if I talk about its position should be in xy plane, because it is rotating along this z direction. So whatever is fixed, that is what not at fixed, that means the particle should be in xy plane, then only it will be able to rotate in the z direction. So that's why r is taken as x comma y comma 0. So now using this formula V equal to ohm into r, I can find out this V. So similarly I can find out this V. Now I got this velocity field vector and also the delta I know. Okay. So accordingly I find out this solution. Okay, so the correct option is option C, that is 80. So I think it is clear to everyone. I think so, and also he answered. Shivam has answered it correctly. So let us move to this next question. So in this question, uh, it is given that a cart is moving at a constant velocity, a constant absolute velocity. So some absolute velocity is given, and say that it is moving in the right side direction. A high speed object, so a speed velocity of a absolute jet is given, and also it is mentioned that it is also moving in the right direction, right side, but it strike the back of the car. So the car is moving at 10 and a jet velocity of 15 meter is striking it. So you are asked to find this relative velocity of the water. So these are the four options. So please try to solve. So Shivam, try. I'm giving you 1 minute time. So Shivam, okay, Shivam was answered option B. So let us move to this question. So to check whether whatever you have answered it is correct or not. So say in this question, say it is the car. It is the car. So it is given this car is moving in the right side and its velocity is 10 kilometer per hour, right? And what is given? A high speed jet, it is striking at the back side. Okay, so it is jet. So its velocity is okay. So what is said that you are asked to find the relative velocity of the water. So whenever in a question it is said that you are asked to find this relative velocity of something, then you have to consider the other body is at rest. So as it is in 10 kilometer, the car is moving 10 kilometer. So we are giving an opposite 10. So if I give it opposite 10, that means the car initially at rest. Since for the car we are giving in 10 velocity in the opposite side, so that the car is rest, then this 10 should be also given here, right? So whatever next, what should the resultant? Now the resultant is that in 15 kilometer per hour should be in the right direction and in the left 10. So there should be minus each other. Okay, 5 kilometer. So the correct option is option B. It's an such types of question you can may come. So please try to go through similar types of question. Now I am moving to this next one. Okay. So this is another question regarding this steady incompressible 2D velocity field. So you are asked to find this velocity of x and y at the stagnation point. So please try. It's a simple question. I am giving 2 minutes time. So please try. Sure. So check or let me know. So uh, just check this thing. So Shivam says that we do not have any idea about this one. So let us check check this one. So what exactly the stagnation point? So the stagnation point, as I have discussed in the earlier class, the stagnation point basically represents this V should be 0. So see, this V is represented in terms of a vector where the x component is this one, right? So this x component of velocity I can write is, say, if V is a velocity vector, so I can write this as a, in term of this, where u is the x direction velocity component and v is the z direction velocity component, and if it's 3D, then w k cap, where w is the z direction, right? So if v is 0, so what I can write this small u should be 0 and small v should be 0, right? Then only v should be 0. Okay. So as this v u equal to 0, that means 2 minus 1.6 x should be 0, and for v, zero point 0.9 plus 1.6 y should be 0. Therefore x should be 2 by 1.6. So what exactly it is? Okay. Similarly, here from here I can also find out this one, minus 0.9 by. So what you will get? You will get answer as 0.5625. Okay. And also a minus sign is there, so there should be minus. So x should be positive and y should be negative. So in only in option B and C, only option B and C are seems to be correct. But here from the B it is get that we get x equal to 1.25. So option C is the correct answer. So I think you got this answer and how to solve this one. So please have a look and let me know if there is any confusion regarding this. So I am moving to this next one. I think it is clear. So this next question. So this next question is a theoretical question where it is asked about the local acceleration in the x direction is given by among these four options you have to choose. So I am giving you 1 more minute. So can you be able to answer this one, Shivam? So I am giving you 1 more minute to check, or will you able to answer? Good, very good, Shivam. So B. So so I am explaining about this question. So basically, in the if I talk about this acceleration in the x direction, what exactly it is? So it basically represents in a, so there should be the derivative in x direction. One, what I know that the velocity is u, so it should be derivative of u. Okay, if it's a transient problem. Next, what I know that it should be the, okay. Similarly, so see this first term is known as transient term. Okay, this is the transient term, and rest term represent our convective term. Okay, so that is the question I asked. If this any of this term is given, then you can say that it's a convective term. But as it is told that this local acceleration in x direction is given, so that's why we have given it in terms of du dt, because it basically transient term, or I can say it is a local term. Okay, so this correct option is option B. So up to this the question. Next, I'm moving to this next question. So that one is the line of contact is there are four options. So please have a look. Check and let me know if you will be able to answer this one. So I'm also giving you another minute time. So do you have any idea? So if you have any idea, let me know. Okay, Shivam. Shivam, no need to worry about this. Sorry. So, so basically, say I am talking about a 2D potential flow. 2D potential flow. So you know about this velocity potential. So this velocity potential, I present it as phi. Okay. So say since it's a 2D, so it should depend on x, y. So what I know in case of velocity potential, what has been taught in this u vector should be the derivative of this velocity potential with respect to x, and for v it should be the derivative of with respect to y, right? Up to this, any confusion? No. Another thing, what I know, that you have studied about this line equipotential. Equipotential line. Say from this line, this is equipotential. That means potential should be same. So equipotential lines. If someone say equipotential lines, that implies this phi is constant, right? Any confusion? Hmm. So gradient. Now divergence, if I talk about this gradient, so that is derivative. So gradient is, so basically gradient means if I talk about say x, ddx of phi plus dx ddy of phi. Phi is a vector. So basically if I take this thing, that means it's a slope, right? So what I can say that if this indicate slope, huh? Okay. So this indicates slope. What slope? This indicates this normal slope. This indicates slope to this constant. Okay. Why you got this point? Because see, if I have to find out this derivative, the derivative basically with respect to some axis, it is your slope. So we also know that the slope and the curve should always be perpendicular to each other or normal to each other. That's why the correct option is that the line of contact should be normal to this streamline. So that is the thing. Okay. I think this concept is clear to you now. Can I move to the next one? Okay. I am moving to this next one. Please have a look. So this one is another numerical problem where velocity is given. So you are asked to find the acceleration. So this is a fresh new concept. So I think you will be easily able to answer this one. So for this one I am giving you 2 minutes time. This is a simple question. Please try. And another thing I just forgot in the previous slide. So in that case, another thing that you please remember, that thing is that this velocity field is always a function. Say if these two, if phi is given, so you can find out u and v. So if someone asks to write this velocity vector, so you remember that it's a function of u and v. So u depends on potential velocity potential. Accordingly, derivative we get u, and similarly this thing. Okay. So please apply this concept. Maybe it is required here or may not be. So you just check. So I am giving you 1 more minute to solve this one. Okay. I think this is a new concept to you, Shivam. Whether you have answered, let me check. No. So okay, I am solving this one for you. So this is our in this question. So what basically is given? This velocity is given, right? So I'm changing this color to another one. So and it is two component are given. So what I know, as I have said, that it's a function of u and v, right? So what is u? See, it's three direction u, v, w. So what is u here? U here is 2, v is x plus y, and z is x, y, z. Okay. So these three things I have got. So this in this question, the what is given, the velocity field in a flow system is given, the acceleration is given. So no details about whether it's a steady or transient problem is given. So we assume this as steady problem, right? So acceleration, what I know this acceleration is, so you know this acceleration formula du dt plus u. So this one plus w into du dz. So these are the terms. So as nothing is detailed, so we consider this term as 0. So assume there is a flow is steady. So I consider the flow as steady, right? Okay. So what is u here? U here is 2. What is the derivative of u? Because it's a constant, so it should be 0. What is v? V is x plus y. So in place of x plus y, the point should be value. What is the point? X, y. Sorry, x is 1, y is 1, and z is 2. So if I derivative this term, v, no need to derivative, x plus y, this is 1 plus 1, 2 into du dy. So this u is corresponds to Hmm. So it is 2 and du dy so d, dy it is also 0. Then similarly this one is 4 and this one is 0. Okay, any confusion? So that's why acceleration in the x direction is 0. So acceleration is in y. So similarly in acceleration y this should be 0. So similarly this vector v will be 0, so I can write in place of u dv dx plus v dv dy plus w dv dz. Similarly for z direction you can find out why here u is dv dz is uh, dv dx is 1. Okay, so then v is 2 into just use as derivative this v term and put this value x1 or y1 z equal to 2 plus 2 into 0 this one is 4. So similarly you can find out az which you will get as 10. Okay, so the component is 0 for 10. In any option it is there. So 3 in 3 option is there, but the thing is that 0 comes for the x direction, that is I cap there should not be any 0. So option B and D will be cancelled out, C will be cancelled out, A. Okay, so the option A is the correct answer. Okay, so now I'm moving to the next one. So I'm giving you 1 minute time for this one. So no, I'm giving you 2 minute time. It's a tricky question, but I think that you can able to answer this one. So please have a look. Whether you will be able to solve this one, or can I go for the solution? So please check and tell. So Shivam has responded that it should be option A. So let us check. So what is given? This velocity potential is given. So in this, if velocity potential is given, I can find out this u and v, right? So what is u? U is this potential function. If we derivative it with respect to x, we will get this function, right? So if I derivative it with respect to x, the first term should be 0 and the next term I will get as minus 6xy, right? And for v, I know v component can, by derivating this potential function with respect to y, I get this v, y direction velocity, that is v. So I will get 3y square minus 3x square, right? Okay. So now what is the velocity field? As I have told, b should be the function of u and v. So that means I can write it as minus 6xy comma 3y square minus 3x square. And that means it is in the x direction, it is in the y direction, right? So I have to check the validity of this potential function. So first let me check whether it is rotational or irrotational. So for this I am finding out this curl. Okay. So what I will get if I find out this thing, so say, so you know how to find out this thing, yes or no? So as it is in two directions, so say what this basically is, say this is I cap j cap, right? And in this I cap, what is there? It should be ddx and it should be ddy, and here it should be minus 6xy, it is 3y square minus 3x square, right? Yes or no? Is it? Okay. And in the k cap, nothing is, as the k cap is not there, so I consider this as 0 comma 0, right? So say, so if you find out this thing, say in I cap this one should be 0 and in the j cap also this should be 0, so only it is found in terms of k cap. So what should be this? It should be the derivative of this one into this one. So if I derivative, say derivative of this one and this one, right? So the first derivative, what I will get? I will get 3y square should be 0 and it should be minus 6x, and the minus should be there, and already it is with respect to, so it is a minus 6x. So that means in overly I will get it as 0 because it will cancel out. So that means this potential function, from this potential function we get to know that it is irrotational. So always remember, if it is given that a flow is irrotational, then it will definitely be a potential function, right? But if it's a potential function, you have to check whether it is rotational or irrotational by this formula. Okay, now I have to check the compressible nature of this flow. For this, I am giving you this concept. So to check whether it is compressible or not, so I am erasing this thing. So to check this compressibility or not, I have to check whether this function should be 0 or not. I have to check this thing. So how to check this thing? What exactly this represents? This represents its double derivative with respect to phi plus double derivative with respect to with respect to x and with respect to y. So now if I double derivative this term, what I will get? First, in a single derivative already I have got say this term. In this term, if I first for a single derivative, what I will get? Just for a single derivative with respect to x, I will get minus 6xy, right? And here for a single derivative, what I will get? 3y square minus 3x square. And again I derivative with respect to x, I will get minus 6y. And here I will get plus 6y, and this term is 0. So also this is getting a 0. So that means it is incompressible, right? So to check the incompressible, it must satisfy this Laplace equation. Okay. So as this potential function fulfill this irrotational criteria and this compressible criteria, that is harmonic. So the correct option is option A. Okay. So I think you got it, and yes, Shivam, you answered it correctly. So now I am moving to this next one. Please have a look. So you just check. So for this one, I am giving you 2 minutes. So please try to solve one. It's based on the same concept that I have discussed earlier. Okay. So please try to solve this one. So see, it's like this concept is this velocity where I know that omega is equal to curl of velocity vector or velocity field. So accordingly also angular velocity formula you have uh, known how to derive this thing. So you can go through this formulation and you will easily able to find out this thing, right? Okay. So please try to solve this one. So this option C. Okay, Shivam is just running with option C. So let's check whether it is correct or not. So first we have to check what is given in this question. So this velocity field V is given, so it has x y three components. So that means small u, that is y square, and V is minus, this one is V is minus x y, and W is 2, right? Okay. So we know this velocity is omega into curl of this vector V, right? So this thing you know. So here we are asked to find what I need to find, that is the z component. I have to find, this is the question. So angular velocity, as I have already elaborated in the earlier one, so I can write, since it's a curl vector, so I can write I j k, and this is d dx d dz, right? So what is the velocity given here? It's y square minus xy 2. So in this question this has been asked, and what we know? We know that omega is 2 sigma, that is the formula we have. So that's why we are finding omega. But this is z, so we have to find only for this z direction. So for this z direction, I have to take only k cap. So for this k cap, so first one, this is the derivative of x, derivative minus xy with respect to x, so that is minus y, right? And similarly, derivative of this one should be minus 2y. Okay, so this is the, yes. So if I only find this vector term, no need to, minus 3y k cap, right? So what is the y value here? Y value is minus 1. So if I put, it should be 3 k, right? Why? Because y is 1. So if I find out its magnitude is 3. So as its magnitude is 3, so I can write ohm z is omega z by 2. So that is 3 by 2, which is 1.5 radian per second. So my correct, or our correct answer is option C. So you understand this concept? I think so. Okay, now I am moving to another question. So in this question, it is asked that this Euler equation, you know, this Euler equation is a fundamental to derive this Bernoulli's equation, as I have discussed in the earlier class also. So in this question, it is asked that this Eulerian equation can be integrated. At when? Thus the question is when. The first is that the fluid is compressible. Next is this velocity potential function exists and the fluid is incompressible. Third is if it is irrotational, or if this continuity equation is satisfied. So this is a tricky one. You need the fundamental basic, and you need to remember a lot of things to answer this one. So first you try, and after that I will solve this one for you. So I'm giving you 1 minute time. So I think I have to solve this one. So let us solve this one. Okay. So I am solving this one. So please have a look. So let me write down this Eulerian equation. Basically, if I write down this equation, so this is the main equation. So no need to remember this. I am just telling you about this concept, right? So this derivation is not that much important. This is density and this is pressure plus G is the body force, right? So if I talk about this Bernoulli's along a streamline, Bernoulli's equation, along a streamline, right? So what are the assumptions? So if I talk about the steady flow, the first is steady flow. What is that means? That means this term should be 0. So in this term, that means it will be 0. Okay. So first, in order to do derivative, this term should be 0. Next is in viscous fluid or in viscosity, and is also another assumption I need to take is this gravity term should be a conservative one. Okay, that is another thing. Conservative body force. I can call it as conservative body force. So see, if I put this thing here in the above, what I will get? So this is basically derivative, right? If I you just forgot about all these things, this is also derivative. This is P, and in place of G, I can write this one. This is potential function. So as derivative is on all the sides, so we can do integration easily. So if you do integration, you will get a term, and this term is here P by rho. Okay, it's minus, so I am just considering it at that side. The 2v is there, so derivative integrating it will be v square by 2. Okay, b square by 2 plus, so that b is I do not know, so I just give mod, and if I take this one, so that constant, so that is the Bernoulli's equation, but that is for a streamline, along a streamline. Okay, so in this equation it is not clear, say it's a potential function is given, right? So a potential function as this, it is given a potential function. So it is not, I can't say anything about this rotational or irrotationality. I have to check whether the double derivative of this one is 0 or not. So accordingly I can solve this one, right? So now I have to check one thing. Just a minute, I am erasing this thing. So first thing is clear, right? So whether rotation I can't understand from this thing. So next is that I am writing this equation again. So this equation is dv by dt plus v dot del v, this equal to minus 1 by rho into del p plus g, where g is minus this one, right? So if I talk about this thing, say if it is not a streamline, okay, if I talk about everywhere Bernoulli for Bernoulli's equation, okay. So already I know that this term I have considered as 0, right? Yes, okay. So just tell me one thing, that if I know if it is irrotational means omega is 0. That means if it is 0, so I can also write, just a minute, let me clarify this thing for you. Huh. So if it is omega 0, so that means I can write this into this one is 0, right? So it is irrotation means it should be a potential function. So also in this potential function, when it will exist, we have studied that this potential function will only exist if this velocity should be derivative of this potential function, right? So v should be this one. Yes. So now in place of v, this one should be there. So previously what I have got, I have got this one plus 1 by 2 b square was there, right? Now in place of b square, I can write equal to constant. Okay. So that is the scenario for this incompressible. Is it clear or not? Just tell. So up to this, any confusion or not? Any confusion? Please tell. So see, just think that this is equivalent to what we have discussed earlier, right? So accordingly, you can solve this one. So why this equation is important? So this equation, so I am just explaining a little bit about this equation. So this equation is important because say here this term is a derivative term, right? So del is there, so it can further be integrated. So this Bernoulli's equation, so previous one is for a streamline, but this Bernoulli's equation holds good for anyone, even if it's a irrotational, right? So that's why the correct option is the flow is irrotational. Okay. So and if you talk about why this option A, B or D is not correct. So in the first option it is incompressible. So compressibility means it affects the pressure density relation. Definitely because it's compressible, so it will certainly affect this pressure and density, right? But that doesn't indicate that you can do integration or not, because what type of function it will be, it will not know. But if it's an incompressible, and then density is constant, so it will come out easily and integration can be easily done. But for compressibility we can't say, maybe it is possible, maybe not, it is not possible, right? The next option is this velocity potential and incompressible. So incompressible it's okay, but the velo velocity potential implies irrotationality. Uh, okay, that is okay, because since in this question this velocity potential function is given, so we can assume that it may be incompressible, and also this uh, fluid is incompressible. So that that can be also answer, but the thing is that we can't say in the velocity potential function about this concept of this rotationality or irrotation. Generally, it is irrotation. So last is this continuity equation is satisfied. So just by ensuring continuity equation, we can't say, because we need the details of this energy conservation equation. That's why. Okay. So that's why this is the correct option. So the option C is the correct option. So always remember, so whether anything is integrable or not, it depends on the path, along a path in the flow. That is the nature of the flow is quite important. Okay, so other thing are not that important. So if any question irrespective of this thing, if say whether it is integration is possible or not, you have to check about this nature of the flow. Nothing else you need to check about, whatever equation on all these things. So nature of the flow is the first and the important thing that you need to look upon. Okay. So another thing, if I talk about this equation, is that for this integration, what exactly we need? Euler-Lagrange equation. First is we need the flow should be in viscosity, it should be steady, and also this conservative body force is required. So if all these thing comes together, then this gives Bernoulli's equation along that streamline, right? So if it is not along a streamline, then we also require irrotational flow, as I have discussed along with the previous three, that is in viscosity, conservative force, or the unsteady flow. That all thing is required. So again, another thing is that compressibility are not a sufficient condition by themselves. So we need to check other condition also. Okay. So option C is the better option here. So we are moving to this next question. So please try to solve this one. This is simple question. So I'm giving you 1 minute time to for this one. So just the fundamental is essential. You can easily able to answer this one. Okay, Shivam has responded quickly. He is in option D. Okay. So without wasting time, I'm going to solve this one. So a stream function. So say if a stream function psi, so psi is a stream function. So it is given. So if a stream function is given, how you will find out this component? Suppose for this potential function, you know that if you derivative this potential function with respect to x, you will get this u, and if you derivative it with respect to y, you will get this b. But if the streamline is given, then you need to derivative it with respect to y to get this u, and for b you have to do the negative derivative with respect to f, that is inverse. For b you should have to derivative in the x direction, for u you should have a derivative with in the y direction, right? So what I know, we know that a streamline, what is a streamline? So is always tangent to this velocity field, right? So a streamline is always tangent to a velocity field or a point, right? So that is the thing. So if I derivative this thing, another important thing is that how to check whether the streamline function, whether the stream function is along a streamline or not. So for this, if I derivative, so that means here you say from this definition of streamline, what is the definition? If I write this definition, a is a curve that is tangential to the velocity field, right? So what is tangent? Tangent means dy dx. Okay. So in the velocity field, there is u vector and uh, v vector. So we, in terms of dy, we can write this as velocity v vector by u, right? Okay. So to check, we have to find out this instant derivative of this one with respect to x. So for this one first we have to do this derivative, partial derivative with respect to x, then partial derivative with respect to y. Okay, as it is in x direction, so using this chain rule I can write, you have studied about this chain rule in math, right? So that thing, what is dou psi by dou x? So as I have said, that is minus v, this one is minus v plus, what is this one? This term is basically u, and dy dx is v by u. So that means minus v plus v, so which is 0. So as this derivative of this with respect to x is 0, so we know that if derivative of something is 0, that means this function is a constant. This implies phi is constant, right? Say, if you do not understand this, is you just integrate this thing, you will get phi is constant. So our correct option is option D, that it should be constant. Okay, so this is a fundamental concept. So I am moving to this next question. I am giving 1 minute time to solve this one. Please have a try. So in for the streamline is it is similar question like the previous one. For the streamline, you just remember the two things. One is how to find this velocity component, that is u and v. U is the y derivative of the streamline function, and v is the negative of negative of y derivative of this stream function, right? and another is the slope. So from this definition onward, we know that dy dx is v by u. So if you remember this thing, you can easily able to solve any question. So please try. I'm giving one more minute. So Shivam, this one is option B. Okay, let us check whether it is correct or not. So, so if u is given, v is given. So first our objective is to find out this path or this streamline function, not streamline function path. So we know that from the derivative that is v by u, and after that it's like this sol solve of this differential equation, which is quite easy. So this one is 6x by y square. So now what I can do, I can take this y square with dy and 6x with dx, right? Okay. So now I am integrating this thing. So by integrating this thing, I will get y cube by 3, right? This is 6x square by 2 plus 3, right? So ultimately this is 3. So y cube, if I have to find out this y cube means because in this option everything is in y cube. So I just take this y cube. So I have to multiply this with here. So 3 is a 9. 9x square plus 6. Okay. So from this thing also we get our answer that it should be either A or B. So D and C will not be answered. Up to this anyone can guess, but you have to find out this value of C. How will you find out this value of C? Okay, it should be 3C. Sorry. So given this point is 1 comma 1. So that means x is 1, y is 1. So I can put it here. So 1 cube equal to 9 into 1 square plus 3C. Right? So 3C is minus 8. So actually we need 3C. So in place of 3C, what I can write, this 3C is minus 8. So can I write y cube is 9x square minus 8. Okay. So additionally I can write this as y cube, this is 8. So that is our final answer. So option B is the correct option. So good Shivam that you have answered this one. So now I am moving to the last two questions for today's in life interacting session. So it is also a similar types of question. So please have a try. So here also a stream function is given and you are asked to find the flow between 2 points. So it's a quite interesting question. I am giving you 2 minute time to solve this one. So so I am just explaining a thing for you. Say if it's a 2D flow, it must be incompressible. So this steam function, what does the steam function value basically get? Steam function means the flow rate. So if you find out the difference of the steam function at 2 points, so that means it's the volumetric flow rate, right? That is the flow between 2 points. So to find this flow between 2 points, you have to find the difference in the stream function. So solve accordingly. So 2 points are given, you have to find this. I am giving 1 more minute. Let's try. So I think, can I solve this one or will you try? Please let me know. So should I? So I think I have to solve this one. Okay, I am solving this one. So please have a look. So in this question, so this concept of this flow. So always remember one thing, the difference in stream function between two streamline values, this equals to what? Volumetric flow rate depth. Okay, so if Q is the flow, I can write that 2 points, say A point, and say this is B point. So this is nothing. That means the 2 points are given, right? So, so between these 2 points, so you have to find this thing. So this is quite simple. So why? So if they say phi 2 comma 0, that means already it is given x square minus y square. Here x is 2 square minus y is 0 square, which means it should be 4, right? Similarly, if you put here 0 comma minus 1, so that means it's 0 square minus 1 square. That means it should be minus 1, right? So here if you put, it should be 4 minus, this one is minus 1. So this one is plus 1, this one is 5. So 5 is the correct option. In the last question, I think I have told about this answer, yes. So the option C is the correct option. That is 5 is the correct option. I think you understand this question, right? Okay. So I am moving to the last question for today's live editing session. So I think that you understand all this question. So before moving to this last question, so remember one thing. So this concept of this fluid kinematics is quite essential. Please go through this lecture provided by Professor Subhashish Datta. So that will definitely help you to improve your understanding about this subject, and he has taught it in a quite easy fashion. And also this numerical, after going through this lecture and all this, if you come to solve this numerical question, it will be quite easy for you. Say whatever the numerical we are solving today, if you there are similar types of question that has been provided in this for assignment, so you can go through this and compare both of these. You will get the idea of how the question is said and what are the way you should have to approach to a problem. So basically that is the thing. And another thing is that if in any concept or anything you found that there is some doubt, or you can raise your concern or doubt through my mail ID, which I have already mentioned earlier. So I'll also provide the same. So if you want to check this previous classes lecture on numerical, so this link will be already uploaded by this NPTEL, from this NPTEL site. Please go through this. Okay. So now I'm moving to this last question. So in this last question, this potential function is given. So you are asked whether what type of flow it is. Either it is irrotational, rotational, or this flow doesn't exist, or like that types of question. So basically, this potential function is given. So it is quite simple. You know this. If a function is potential function, you can find out this velocity field and also check this irrotationality condition, right? So please check and tell me what is the solution. So I'm giving you 2 minute time to solve this one. So this is the last question. So please check this condition. So basically you need to find omega, nothing else. First check omega. If omega is 0, then it is irrotational. And if it's not 0, then it is rotational. So this condition you need to check. So I think that is a quite simple question. Okay. So Shivam respond that it is option B, that is rotational. So let us check whether you are correct or not. So in this question, there is already this potential function is given. So potential function e to the power x plus y. Okay. Sorry. Uh, e to the power, there is mistake in this question. It is e to the power x plus iy. Okay. So it's a mistake in this question. Still check. Uh, so this is mistake from my side. So you rectify this thing. So as this is given, so I can find out this u. What is u? U is that its derivative with respect to x. So if its derivative with respect to x is the same thing, right? Okay. So now for b, it should be this derivative with respect to y. So that means y means I will come out as a constant and e to the power x plus iy. So that will be the value. So I got u and b. Okay. So that means here if the velocity, we know this is u comma b, I know. So again omega, what is omega? This omega is curl of this velocity vector. So I can write this one is I cap j no j cap k cap, right? So it is in two directories. So that means these two should be 0, and here I can write the x, and here I can write y, and this one is u. What is u? U is e to the power x plus iy, and it is I e to the power x plus iy, right? So as already I have to, these two is 0, so the I and j should be 0. So in the k cap we get our answer, right? So in this k cap, and that is that, what should be? It should be derivative of this one. So in the x direction, again this is I e to the power x plus iy, right? Minus this one derivative of this one. Yes. So what should be the derivative of this one? So check, this one is u. First u derivative, and sorry, it is the derivative of this one. So this one is I e to the power x plus iy. So this one should be 0, right? So that means omega is 0. Omega is 0 means I can say this one is 0. That is curl should be 0. So if something, if the curl of vector is 0, that means it indicates that it should be irrotational. So Shivam, I think your answer is also correct, because maybe you answer because this question I have mistakenly written as x plus y and it should be I plus y. Now you understand this thing? Okay, good. So with this today's live interactive session comes to an end. I will share this slide with you. So if you find any confusion, please feel free to contact me. You can raise your concern through my mail ID, and all the best. Shivam, thank you for joining. So any concern, if you do not have any concern, you can leave. Okay, so you can leave now.